Hello, boys and girls. We're going to do our math lesson today, and today we're going to be looking at multiplying numbers. So we're going to go ahead and do three quick hamburger folds, right, as we usually do in math. And once we've done our three quick hamburger folds, we're going to go ahead and I'm going to draw in my lines. You do not have to, but I like to draw in mine so that you can see my paper a little bit better on the camera. So we're going to be looking at multiplying numbers, and which seems appropriate since we've been talking about factors and multiples, right? So we're moving on to the next stage, and that is multiplication of numbers. We're going to start out with single digit multiplication, and then next week we're going to get fancy and we're going to do double digit multiplication. So today's lesson, make sure you write your name at the top, and we're going to write on here that it is lesson 3.1. And we are going to be on pages 92 to 95. Okay, so I'm opening up my math book to 92. And we're going to talk about multiplying, what happens when we multiply one-digit numbers. Okay, so again, we're using our same place value model, which is really helpful. Remember, it was color-coded. The ones were turquoise, the tens were pink, and the hundreds were lime green. So as we're working on this lesson, what we're going to do is we're going to use different methods to multiply four-digit numbers by one-digit numbers with or without regrouping. So one way to do this is by using repeated addition. So we can say that 213 times 4 is the same as 213 plus 213 plus 213 plus 213. So that's one way of showing multiplication. Another way is we can show it using a rectangular array, right? So if we look down here, we can say, okay, this is 213 times 4, right? There's 200s times 4, 110 times 4, and 3 ones times 4. And that's going to equal 4 times 213 equals 3 ones times 4, 110 times 4, and 200s as 4. Now, when we do multiplication, the traditional algorithm focuses on this. And so we're going to focus on it as well. Another way to demonstrate one-digit multiplication is to use the area of a rectangle. Remember when we had area charts? So this is showing this whole length is 213, and then we've broken it by place value. Here's 200, 10, and 3, 213, and we're multiplying by 4. So we can multiply each chunk by 4, add all the chunks together, add the partial products together, and that's going to give us our answer. So we're going to do a little bit of all three methods. We will mainly go back to using this method. The first method, repeated addition, is not very efficient, especially when you start multiplying larger numbers. It's not as an efficient strategy as using a rectangular array. All right, so let's look at number 1. Number 1 is asking us to use repeated addition. And I'm going to turn my paper a little bit this way because it has us listing it with 4,522 times 5. And it says that that equals green box plus green box plus green box plus green box plus green box. So if we're using repeated addition, it means that we're taking this number, 4,522, and we're adding it 5 times. So that would look like this. Now, that is not very efficient because what I'm going to have to do is stack these numbers, right, to do this, because I can't add them this way. That's too crazy. So I'm going to go ahead and stack them. I have to make sure, whoops, I have to make sure that I have 5 of them. And I'm going to go ahead and add them together. So I know that 2, 4, 6, 8, 10, regroup. 2, 4, 6, 8, 10, 11, regroup. 5 plus 5 is 10. Well, actually, we have 1, 2, 3, 4, 5. Times 5 is 25, plus 1 is 26. Regroup. 1, 2, 3, 4, 5 times 4 is 20, plus 2. So my answer is 22,610. So that was not very efficient. And you probably noticed that I just automatically started multiplying using multiplication. This is 2 times 5, that's 10, right? And especially when I got to the 5s, I was able to just go, oh, that's 5 times 5 is 25, right? You will find that repeated addition ceases to become a useful strategy when you get to 4th and 5th grade. So I used to teach 3rd grade, and I had a student named Jacob. And Jacob was really smart, but he refused to learn his times tables. And he was a 3rd grader, and 3rd grade is the year when you learn your times tables. He refused. He said, I'm just going to add. I'm going to use repeated addition. And I remember I said, okay, that's going to be fine for this year in 3rd grade, but it's going to start getting harder for you to use repeated addition. I don't care. I'm not learning my times tables. Okay. So when he was in 4th grade, he came into my classroom and just said, his last name was Vowinkle, Jacob Vowinkle. He came in and he said, I just really wanted to tell you that you were right. He said, you were right. I really had to start learning my times tables because I couldn't do math very well using repeated addition in 4th grade. And I thought you'd like to know that you were right. And it made my day. It made me laugh really hard. So this is a strategy that you can use, but it's going to be much more efficient as you start dealing with larger numbers. It becomes more efficient to be able to use multiplication. So looking at number 2, we have a big problem that looks like we have a whole bunch of thousands, right? So we're looking at the array, and if we counted how many, I'm counting right now that I have a certain number of ones, right? I have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 thousands, right? And then I have quite a few hundreds. So if I go ahead and I'm multiplying, actually, if I look at it, I'm multiplying by 3. So if you look at this picture, each one of these rows represents 3. So I'm multiplying, I'm going to fill a 3 into each one of those. And then I'm just going to count how many are across. Okay. So to start out with, I have blank thousands times 3. And I know I have 3 rows. And I have 4 in each row. Okay. Then I have in the hundreds place, I have 1, 2, 3, 4, 5, 6. I have 6 hundreds times 3. Then in the tens place, I have 3 tens times 3. And then in the ones place, I have 4 ones times 3. So if I were to look at this rectangular array, what is our big problem? We have blank times 3. Well, it's probably going to be 4,634. Right? And that makes sense looking at the picture. So if I were to do the ones first, right? If I were to say, okay, I have four ones and I'm multiplying them by 3, what do I get when I do that? If I have 4 ones times 3, I'm going to get 12 ones, right? So I'm going to say, well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's going to give me 12 ones. If I have 3 tens and I multiply them by 3 rows, I'm going to have 9 tens. If I have 6 hundreds and I multiply them by 3, I have 18. If I have 4 thousands and I multiply them by 3, I'm going to get 12 thousands. Right? This is without regrouping. So we would definitely have to regroup to do that. This would be, sorry, the neighbors are super loud right now. There would have to be regrouping here and here and here. And when I regrouped here, it would cause this to have to regroup as well, right? Let's look at number 3. Number 3, I have a chart, and I'm going to turn it to the side. Actually, let's solve this one. Let's solve this one by lining it up and laying it out. So if I went like this, and I had 4,634 times 3, I would have 4 times 3 is 12 ones, right? Regroup. 3 times 3 is 9, plus the one we regrouped is 10. 6 times 3 is 18, plus the one we regrouped is 19. And this would be 4 times 3 is 12, plus the one we regrouped is 13. So I would end up with 13,902, which is the exact same thing as this. We just didn't do any of the regrouping here, right? Okay, let's look at number 3. Number 3, I have a chart, an area chart, which I'm going to draw in. This is 6. This is 1,378. And then down here, we're going to take chunk A. And chunk A is going to be 1,000, right? Chunk B is going to be 300. Chunk C is going to be 70. And chunk D is going to be 8. So we've just broken this number up by place value. This is 1,000, this is 300, this is 70, this is 8. And now what we're going to do is we're going to multiply 6 by each one, right? So the area of D is going to be 6. We'll just say D equals 6 times 8. Oh, I guess they want you to put the 8 here. 8 times 6. The area of C is going to equal 70 times 6. The area of B is going to equal 300 times 6. The area of A is going to equal 1,000 times 6. Okay, so then what we're going to do, once we figure out what all of these are, we're going to add them together. So 8 times 6 is 48. 70 times 6 is 420. 300 times 6 is 1,800. And 1,000 times 6 is 6,000. Now these are not lined up. They're lined up backwards. So we're going to stack them. I'm going to flip them. And when I flip them, I get 8, 6, 12, and this is 8,000. So my answer for the total is, if I added each one of these boxes, each one of these partial products together, I would get 8,268. Okay, now we're going to look at modeling multiplication, and we're going to show all the steps. So if we look at our math book and we look at this page over here, this problem that we have, we're looking at, let's see, I think we're only going to 95, right? So we can write this out. We'll write out step 1, step 2, step 3, and step 4. So let's look at the steps. We have Roy's Market sold 2,476 oranges. Anna's Market sold 3 times as many oranges as Roy's Market. How many oranges did Anna's Market sell? So we're going to take the oranges, 2,476, and we're going to multiply them by 3. I'm going to, if you guys don't mind, I'm going to go close the door. The one neighbor is playing really loud music, like kind of beyond loud. All right, so we're going to take this number. We're going to start out right here in the ones. So we have 3 rows. See how we have 3 of each row, right? And this is 6 ones times 3, so there's 6. There's 3 rows of 6. And when I have 6 times 3, I have too many. So I'm going to take 10 of those, which is what has been put in gray, and they're going to regroup over here to the tens place. We're going to cash them in for one of these pinks. That leaves us with 1, 2, 3, 4, 5, 6, 7, 8 left, right? And that's what this looks like right here. 6 times 3 is 18. We regrouped. We cashed in 10 of them for one of the pink. Okay. Now we have 7 rows of 7. There's 3 rows of 7. And we also have this extra one that we added in. So that means we're going to have a lot to regroup, right? We're going to count out. If we counted out, this would be 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That means we have 20 that we're going to cash in. And then we're going to be left over. We're going to have 8 left over, right? So we have Oh, I'm sorry, 6, yeah, 7, 8. And then we're going to cash these guys all in. Actually, no, sorry, we're only going to have 2 left. We're cashing these in for 2. So we're going to take these over to the hundreds and we're going to cash those in for 2 of the hundreds, right? And that leaves us with 2 left. The one we regrouped and the other one. And that looks like this, right? So we did 7 times 3 is 21, plus the one we regrouped is 22. So we end up with 2 left, and we swapped 2. We regrouped 2 over in the hundreds place. Now, when I multiply 4 hundreds times 3, I'm going to get too many hundreds. I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 that I'm going to have to cash in over here. I'm going to cash those in for 1 purple. And then I'm going to end up with only 4 left, right? So that's this next step. 4 times 3 is 12, 13, 14. Here's my 4, and here's my regrouped purple one, right? And then I'm going to do the last step, which is 2 thousandths times 3 is 1, 2, 3 rows, 6, 7. So I have 7,428, right? So Anna's market sold 7,428. So what we're going to do is we're going to go through each one of these steps and we'll just write them in each one of the slots, okay? I'm turning my paper this way because I think it's going to be easier to see. So in the first step of number 4, we're going to call this step 1. And step 1, we're going to have 6,139, right? This is thousands, hundreds, tens, and ones. And we're going to multiply it by 9. So what we're going to do first is we're going to multiply the ones. So we say 9 ones times 9 equals 81 ones. And if I have 81, 1 goes down here and the 8 is going to have to regroup, right? And that's step 1. Now we're doing step 2. Hope you can hear the lovely ice cream truck. Sometimes I just think that this little alleyway is the noisiest place on our planet. So we already did this part of the problem. We regrouped 8 up here and we got a 1 down here because we got 81. Now I'm going to multiply 3 times 9, right? 3 times 9 is 27, and I have to add these 8 I regrouped. So it's 27, 28, 29, 30, 31, 32, 33, 34, 35. So I end up with 5 here, and I regrouped the 3. That was step 2. Now we're going to do step 3. So we already did this step. We got 81. We did this step. And now we're going to do the hundreds place, right? So we're going to multiply 100 and 1 in the hundreds place times 9. That's going to give us 9 plus 3 we regrouped is going to give us 12. Okay? And then we have our last step, which is step 4. Whew, glad that music stopped. They just moved to another street. Okay. So we're always starting with our ones. We did this, we got 81. We multiplied 27, we added 8 to it, and we got 35. We multiplied 9 times 1, and we got 9, and we added 3 to that, and we got 12. And now we're multiplying 6 times 9, which is 54, plus the 1 we regrouped is 55. So the 4 steps that we did, step 1 was the ones. Step 2 was the tens. Step 3 was the hundreds. Step 4 was the thousands. Okay, so each time we're multiplying, we start in the lowest place value, the ones place, and we work our way across. And our answer is 55,251 oranges. Our problem was Roy again and Anna selling 9 times as many as Roy. Okay, so hopefully that helped you to understand that there are different ways to represent multiplication. There are 3 different ways. There is repeated addition, which, as Jacob Bowinkle can tell you, is very inefficient. And probably by now that you're in 4th grade, it starts to become really inefficient. By the time you're in 5th grade and your teacher's asking you to multiply big, huge numbers and you're trying to add them together, you're going to be very frustrated. So repeated addition is okay if the number is small. I would say this is too much. If I have to add this much, it's too much adding, right? So if it's a smaller number, let's say that it was a number with place value in the hundreds, then it would not be as inefficient. But as numbers start to get larger, it's a little bit cumbersome to add them together. The second way of doing multiplication is to use a model with chips, like an array model that shows the chips, right? And you break apart by place value. The third way to show place value when you're multiplying is to make an area chart, right? And you break up the number by place value, just like you do in the area or in the array chart as well. Only instead of having little chips in here, you just have a representation of the number. Okay? So our book likes to show multiplication in different ways to help you understand it. The way we are most comfortable and that we're going to be multiplying the most comfortably is this way, right? We're going to be using this traditional algorithm, starting with the ones place, multiplying the tens, multiplying the hundreds, multiplying the thousands, right, diagonally across. This is the algorithm that's most familiar to everyone, most familiar to your parents, will be most familiar to you. Okay, so hopefully you enjoyed learning how to multiply a 1-digit number, and eventually we're going to multiply 2-digit numbers. Dun dun dun. And you'll like doing that, it's pretty fun. All right, thanks for joining me, and I will see you later.